Welcome and thanks for joining us. My guest today is Vlad Bacalu. He is the Senior Vice President for Strategic and Technical Solutions at Amentum. Vlad, good to have you with us.
Thank you for inviting me.
And our topic today is digital engineering. It's a word we hear a lot. It's something that the Defense Department says it wants to pursue and have its contractors pursue. I'm not sure everyone understands the full implications of it. So maybe give us the brief primer on what digital engineering is really all about.
Sure. So digital engineering is not really a new concept. It has been used in World War II with the complexity of military equipment. It has been used when multiple disciplines had to be brought together to work on large complex systems. Since then it evolved and it became more known in complex systems that require, again, bringing in mechanical engineering, electrical engineering, and other disciplines together and work on those systems. So in the early 2000s, a new concept was developed called model-based system engineering. The idea behind this concept was to, it came about as an alternative to replacing documents and paper-based information with models that can be shared and used by the different disciplines that are working on the complex systems. So everybody has the same view of the same model that simulates the asset or the system, and then collaboration can happen that way.
So that was related in some ways to the rise of CAD and CAM, which is, I guess, a subset of the whole digital engineering idea, but you could have a visual model that was accurate, and we had the computer power to be able to develop those models and share them across networks.
Correct. So as you said, initially there were the 2D AutoCAD drawings that were used for the systems, then those evolved into creating 3D models that allow us to see the interaction between where pipes are going and where the walls are and how they interact with the real system. But then a newer concept with the model-based system engineering, you might add certain metadata to those models where you have information about manufacturer information, switches, for instance, and part numbers that are added to that model. A good example is probably we all remember well, some of us that are older remember the incident that happened with the Mars orbiter that was launched in the 1998, I believe, and it actually arrived to Mars, but it crashed in the Mars atmosphere in the early 1990s because of a miscommunication that happened between the NASA Jet Propulsion Lab and the contractor. So NASA was using metric systems where the contractor was using English mm-hmm. or imperial systems. And because of this miscommunication, obviously the calculations were wrong and we lost that orbiter. If we would have used model-based system engineering and have a clear model that actually simulates the behavior of that system or orbiter in this case, that would have helped eliminate that problem potentially.
So the more metadata that you have about smaller and smaller units or components of a given system, the closer you get to the ideal of digital engineering, sounds like.
Correct. And with digital engineering, we have different concepts within digital engineering, and Amentum offers advanced engineering and mission support systems to our clients in different sectors, from defense to intelligence to defense intelligence, homeland security, and even space. And in those areas, we help our clients with decision making and analyzing their requirements, and then helping them build the right systems. Another area that's really where Amentum is very successful is analyzing large amounts of data. It is not uncommon for a fighter jet, for instance, to produce terabytes of data during a single mission. Now, some of that data is related to the actual mission, like telemetry and altitude and that, But a lot of the other data is also related to the operation of the jet, the function of the engines, a lot of parameters that are received. And we are very successful at analyzing that, the data, and then determining some models where we can predict failures before they actually happen.
Yeah, and that's predictive analytics is one area, and also change management, because in the design of so many military platforms, so many systems of all sorts, people discover things along the way, and that causes a change. Changes cause delays and add cost for things that might have been foreseen if you had a better digital model. So is it the case that digital engineering can help with change management and maybe get to changes before they become expensive?
Correct, very true. And digital engineering actually has three main components, in my mind, just a little bit oversimplifying the situation, but you have a component of digital engineering that addresses the requirement management. So envision that somebody wants to design a new system, somebody wants to build a new asset or anything, basically. The requirement management is an area that Amentum is very strong at and gathers all the requirements, making sure that those requirements are documented and that they meet the mission that the clients have. The second part is change management that you were referring to. The change management component is very important as well, because we all know that during a project we have situations where things change. Some things might not work, or new expectations or requirements come in. So again, we are very good at analyzing those changes, and even more importantly, going through a risk analysis where we look at the risks associated to making those changes and making sure that at the end of the day, the main objective of that system is maintained. And then the last component is the configuration management of the system engineering.
All right, and configuration management means what?
Configuration management refers to the entire life cycle of the system or the asset or the part or jet or whatever we are referring to. And in this life cycle, we are talking about the design phase, the installation phase, the commissioning phase, and then the operation and maintenance phase, which takes the longest part in this life cycle. And then on the back end, we talk about the decommissioning and then disposal of the asset in the proper way. So because the life cycle of the asset, as I mentioned, and the middle part, the operation and maintenance, is the longest segment there that can go for tens of years in some cases, there are a lot of changes that occur there. So you might have new technology that has to be introduced, right? Or you might have modifications to the system that based on new requirements that happen years down the road. So change management makes sure that all these changes are tracked and that they are validated, and that at the end the function of that system is maintained as desired. Change management is probably one of the most complex parts of system engineering, because the other parts, as I mentioned, they deal with the beginning and they have a shorter lifespan where change management goes over the duration.
It strikes me that the data gathered from different iterations and operational data sets from a given platform can, one, improve what comes next. Say, the B series of a given platform and the C series.
Exactly.
But at the same token, that can also go back and improve the model itself, so that the digital engineering fundamental algorithms get better over time as they're almost trained, if you will, to use an AI expression, with data that's garnered in reality.
Exactly. And one area that Amentum is developing, and we set up a strategic partnership with a company called BSCode, and that combines our strong engineering capabilities with their digital twin modeling processes. So as you mentioned, creating these models and then even simulating those models as they as the real system is acting is very important. We had very successful projects developing models for complex equipment sustaining mission for many of our clients in different sectors. And we use those models for training purposes, but also to analyze certain risks that can happen. So, for instance, a digital twin is more than just a 3D visualization, right? It includes that, but it also has the ability to act like the real system is acting. So if I would have a digital twin of this room, then I would be able to click on the light switch and the room would light up, right? In the model would light up. Same with systems that have pumps, motors, equipment that I can control, and then I can see how it reacts. Again, great training tool for their purposes, but also I can simulate now different risks that are happening if I don't do the right sequencing and I don't do the right parts in the right order, or I stop something that shouldn't be stopped.
And you mentioned digital engineering in a fashion during World War II, and the platforms of those days were purely logic with relays, electromechanical types of systems. Highly complex, way more complex than people realize. I mean, you pull apart the wiring harness of a car from the 1930s. There's a lot of wiring in there. But relative to today, it's much simpler because of the degree to which software has been introduced in every phase of every system of every platform. A car today has 50 microprocessors. I imagine a submarine has 200,000 microprocessors or something. My question is, does the digital engineering principle apply to both the electromechanical physical properties, but can you also model software behavior?
Sure, and digital engineering applies very well to software and software development especially, where again, talking about those components of system engineering where you have the requirements management. So with complex software systems, you have to keep track of all the different requirements in different areas, right? Because you mentioned the cars or planes, or they have a lot of different things that are controlled by many microprocessors or computing power that has to communicate each other. So the requirement management, and then also the configuration and change management are also important parts of digital engineering in the software area. And within Amentum, we actually have a couple of software centers of excellence where we develop software for our clients from the Navy or other sectors, and we use digital engineering and especially model-based system engineering during the development of the software and then the validation of the software. A good example would be projects we do with the U.S. Navy in the Dahlgren area, where we use software development, but then model-based system engineering helps us validate and keep us on track.
Sure, where they fire off the shells to see how they perform as they shoot them downriver down there.
That is one on ammunition, but it's also about modeling different systems that ships have. And then more recently, a lot of activities happening around electronic warfare and those sort of things.
And very often failure in a system, whether it's a mechanical failure, metal fatigue or something, or a software failure, is something that's very hard to anticipate even when you think you know everything. And often analysis after the fact reveals that very tiny variations that were almost invisible at the outset multiply over time to the point where you have catastrophe. It's like if you aim a ship toward Hawaii and you're 1 degree off, you can't even see it. But by the time it gets to Hawaii, it's missed it by thousands of miles. That kind of thing. Can digital engineering help with the projection of failure mode and therefore help avoid a lot of cost and maybe some real catastrophe down the line? Yeah,
and a good example in that area is developing certain bots, like robotic software systems, that actually could monitor different events and situations that at one point led to a failure, right? So I know that if I do X, Y, Z, and every time I do XYZ, a failure occurred. So now by monitoring these conditions, we can definitely prevent those failures, because we know that the trend is if these conditions occur, I'm going to have a failure. So that is what predictive analytics is looking at, and that is what Amentum has a lot of experience in the data analytics and processing and visualizing a lot of the data.
And maybe just describe Amentum's product a little bit. If someone contracts with Amentum, what is presented to them on their screen?
So Amentum is mainly a service company, right? So we have products like we develop software for certain clients, we develop some prototyping for parts that are not available, but in general, our expertise are into advanced engineering services. And we provide these expertise to support the mission of our clients, which can be in different industries, but we are supporting them there. And we do that through applying, again, the digital engineering models and mainly model-based system engineering, which is the newer concept.
And I wanted to ask you about infrastructure, because infrastructure planning, infrastructure maintenance is a huge area of engineering. But as the country hopes to spend money on new infrastructure and trying to find new infrastructure, you get a host of other effects that come into play. Environmental impact, what communities will this go through? And it seems like often projects get delayed because of those concerns, sometimes infinitum. They never happen. Is there a way for digital engineering to expand into those realms outside of the product itself to the environment in which it operates and be able to understand those variables?
Yeah, digital engineering can help especially in the early phase of developing some new infrastructures or buildings or even parking garages, right? And a good example there is the trend and the movement toward EV, electric vehicles. Those vehicles are a lot heavier than a regular vehicle, size to size, comparing the same size of vehicles. So again, modeling the infrastructure of a simple parking garage that's maybe a multi-story garage has to take into the account the excessive weight. Then, of course, the potential dangers associated with charging and charging stations and those things that, again, as we move into these new technologies and new areas, digital engineering help us model and even take an existing model and see how it behaves when we start adding more weight to it or changing the purpose, which happens quite a lot.
Yeah, there have even been federal buildings over the years that have been in threat of collapse because of how much paper is stored on the floor, let alone electric car batteries. I can imagine. I guess the final question is maybe take this back to the engineer for us, or the program manager who's overseeing engineering of a project. How can digital engineering make them better?
Well, they have at their disposal now all these tools or components of digital engineering. So if I'm a program manager, then I have the requirements management that's fully documented process on what I need to have to deliver the mission. Then I have the configuration management, which allows me to make changes and keep the systems up to date and be able to monitor the outcome of those changes and without impacting anything or affecting the function of whatever I want to achieve at the end of the day. So overall, especially using model-based system engineering, which has the models, these visual models that I can play with, I can simulate different situations, it's a tremendous help.
So it can make you a better program manager based on having real data from the system it is that you're shepherding.
Yeah, so data is one aspect. It's also the leadership aspect, and combining all these together, people have a lot more at their disposal today than what they used to have in the past.
All right, some great insight. Thank you very much. Today's guest has been Vlad Bacalu. He's the Senior Vice President for Strategic and Technical Solutions at Amentum. I'm Tom Temin from Federal News Network. For more on this discussion, please visit federalnewsnetwork.com and search Amentum.